Hello viewers, welcome to another section of my tutorial, and I have a problem in applied electricity. It's an application of reciprocity. So let's see how the problem says, or what the problem says. It says consider the figures A and B below and find the current in amperes in the 1 ohm resistor of figure B. So let's see. So we can see that these two figures are similar, and we are having the voltage source in different branch and of different magnitudes here. So we have to find the current in this 1 ohm here. How do you go about that? Now let's see if you can find a value for R here, which is an unknown in this circuit. So let's see. You can see that if you take a loop that is from this side, the voltage source is 11 volts, and that is 11. So if you apply the Kirchhoff loop law, you are going to get 11 to be equal to the voltage sum of voltage drops, and there will be a voltage drop across the 5 and a voltage drop across the 3. So making the current which is coming here to be 5 amperes, it was split into I1 and I2 of unknown magnitude. So right now you can see that if I take this loop, I'll get 5 multiplied by 1, that is the voltage drop across here, plus 3 multiplied by I1. So from here, I'll get my I1 to be 2 amperes, meaning 2 amperes is flowing through the 3 ohm resistor. Now let's see. To find the current passing through this branch is simply 5 amperes minus 2 amperes. That will give me 3 amperes here. So now let's move ahead and see how you're going to get the value of R. Now we know that the current passing through this branch is 3 amperes. Then we have to know the voltage so that we can find the total resistance from our calculation. So let's see. This is the entire voltage source, and there is a voltage drop right here, and that is 5 amperes. So to find the voltage across here and here, which are in parallel, and the voltage will be the same, we have to subtract this voltage drop from the main or source voltage, and that will give us 6 voltage. So meaning 6 voltage is across 3 ohms and across this branch. So we now know that the voltage across this branch is 6 voltage and the current is 3 amperes. So to find the total resistance, we are going to get 6 over 3, and that will give us 2 ohms. So if the total resistance is 2 ohms, meaning this R here is 0. So now let's come back to the question. Now, applying reciprocity is saying that if the current in a branch and the voltage source in a branch are interchanged, the same readings are made or the same readings are taken. So let's see. We are comparing these two circuits and we want to find the current through this branch. What do? We have to make this look like this so that we can use proportion. Now we have to interchange the position of this source with this so that to look exactly as what you're having here. So that's where the reciprocity was set in. So in order to change, or in order to shift this one to this side, you have to know the current flowing through this branch, and we will replace it with this voltage source, and this will come here. So now let's see how you do that. So we will draw the circuit and you do the necessary thing. So you have the 3 ohms, but the voltage source will now come here nicely. We are redrawing circuit A, and here will come down, and here will be our current through the 3 amperes, sorry, through the 3 ohms. Then we have our 2 ohms, and finally our R will go because it's 0. So here is 2 ohms, here is our 1 ohm, but the current that will be coming here is going, because the source has been replaced here, so the current will be coming down now, and that's going to be 2 amperes. Here is my 3 ohm, and finally here is my 11 volts. So I can say that this circuit, which is now a circuit A, is similar to this because the same where the voltage is here, and now where the voltage is also the same. So by proportion, if 11 volts is producing 2 amperes in this 1 ohm, what will these 20 volts produce in this same 1 ohms here, since the circuits are similar? That is where the proportion sets in. So if 11 is to 2 amperes, then what will 20 volts be? We don't know. So we know that 11 is small and 20 is big. So if more, let's divide. So we're going to have 20 over 11 times 2, and that is going to give us 20 on 11 times 2. That will give us 3.6363, so let me 3.64 amperes. As simple as that. So this is how we apply the reciprocity to solve cases like this. So you first make sure that one circuit look like the other. The one they've given you to find the current in will be the circuit you put down, but you adjust the other circuit so that it will look like that. Then after, you use proportion to do it. Thank you for watching, and kindly subscribe and also share.